In this video, I'll be showing you how to run the u-track3D software package. I am using a Linux system with 512 gigabytes of RAM, but we have also tested the software with the example dataset on a 32 gigabyte machine. You can find the latest version of u-track3D by visiting our GitHub page, github.com/denuserlab. I've already opened up MATLAB and added the u-track3D folder with its subfolders into my MATLAB searching path. Because u-track3D uses MATLAB's parallel pool, it is best to start it before running the package. Click Start Parallel Pool in the lower left corner to initialize it and wait until it is ready for use. To start up the package, enter u-quantify in the command window. Hit Enter. This will open up a window where you can input your data and select the u-track3D package. Before we can run the u-track3D package, we have to create a movie data object from our raw data. Click New. This will open another Movie Edition window. We will use the Channels option to create a movie data object from the example dataset. This is the raw data I'll be using for this demo. It is a single-channel 3D movie with 51 frames, and each frame contains 61 slices along the Z-axis. Click Add Channel. Navigate to the folder for the first channel and click Open. Now, Channel 1 has been added. On the right, I will input the parameters for this data. The pixel size is 100 and pixel size Z is 350. Next, we'll select our output path. Click Select Path. I'll use this analysis folder to save our output. Click Open, then click Save to save this movie data file. Another window will pop up, prompting you to enter a name for the movie data file. I will use the default name, moviedata.mat, by clicking Save. Now, I have created my movie data shown in the left window. Click u-track3D and then Continue to analyze your data using this package. This is the u-track3D package. It has 7 steps. To run this package, we'll first click the checkbox next to the first 3 steps, then click Setting for Step 1, Render Full Maximum Intensity Projection. Since I only have one channel, I'll use the default parameters and click Apply. Next, click Setting for Step 2, Point Source Detection in 3D. The detection parameters propose different algorithms for detection. The default approach is the one presented in the u-track3D paper. The alpha value defines sensitivity, and the scales field defines the scales used for filtering. Here, I will use the default parameters. Click Apply. In the settings for Step 3 tracking, you can adjust the parameters, including the maximum gap size and the minimum track length. The settings for frame-to-frame linking and gap closing, merging, and splitting are configured in separate windows. Here, I will use the default parameters as well. Click Apply. Once the parameters for steps 1 through 3 are set, click Run. As it runs, you'll see green check marks appear next to each step. When all selected steps have finished running, a pop-up window will appear that says, "Your movies have been processed successfully." Click OK. We can view the detection results by clicking Results in Step 2. A built-in viewer included in the package will open. Click Show in 3D to play the 3D detection results overlaid on the raw image for a specific frame. Click Stop Rendering to stop playback. Results can be seen overlaid on maximum intensity projections. Click 3 under Render Full Maximum Intensity Projection in the Image panel. In the Overlay panel, uncheck Detected Objects by Z-Slice and check Detected Objects under Point Source Detection in 3D. Click Run Movie to see the detection results on all 3 MIPs. Click Stop Movie to stop playback. You can use the Zoom In tool to take a closer look at the results on a specific region. By selecting Tracks and Static Tracks under Tracking in the Overlay panel, you can view the trajectories. When you are done reviewing the results, you can close the Viewer window. The Movie and Movie Options windows will close automatically as well. The estimation of trajectories opens the door to Step 4, Build Dynamic Region of Interest. Here, I can select the type of dynamic ROI estimation from the Type of ROI drop-down menu. Make sure the previous completed detection process and tracking process are correctly selected. I'll use the default parameters and click Apply. Then click Run to run Step 4. After it's done running, you can click Results from Step 4. Click 3 under Render Full Maximum Intensity Projection in the Image panel, then click Run Movie to review the dynamic ROI location on the MIPs. Select Dynamic ROI Raw Image in the Image panel. I adjusted the depth slider to view a specific slice for better visualization of the results, then move to the first frame. Click Run Movie to view the voxels defined by the dynamic ROI. To save the movie, check Save Movie and select a format AVI is recommended. Play the movie from the first frame to the last, then AVI file will be saved. The last three steps, steps 5 to 7, behave similarly to steps 1 to 3, except that the previously completed Build Dynamic Region of Interest process needs to be specified using the Build Dynamic ROI Process drop-down menu for the steps to run properly. I'll keep the other parameters as default. Now I'll click Run to run steps 5 through 7. I've finished running the u-track3D package to analyze my data, and these are my results from the final step. Click 3 under Render Dynamic ROI Maximum Intensity Projection in the Image panel. Uncheck Tracks and check Static Tracks under Tracking in Dynamic ROI, results in the Overlay panel. Click Run Movie to view trajectories over the defined dynamic ROI. You can go back and click on the results from each step. It's a good idea to check the results between running each step. You can also change the parameters of a previous step and rerun the package again. To exit the package, click Exit, or simply close the window. Thanks for watching.